All right, so here's another example. So we know we have a method to find the slope of the tangent line that is using the derivative. The derivative is a limit. The computation is often tedious and technical, but it's doable, and that's sort of the important thing. So in some sense, when you get a problem that says like when f of x is this, it follows that f prime is that, the tedious but doable computation has already been done for you. So now, with this information in hand, we can step forward into asking ourselves a more interesting question, which is we want to find the equation of the tangent line at x equals 0. So here's the thing to think about. You know your original function is this, and you know for any function, it's going to have a value when you plug in x equals 0. And at that point, at x equals 0, there's going to be, when you zoom in, a tangent line. That tangent line is going to have a particular slope, dictated by the derivative. But the long story short is that line, like any line, has an equation. So since we are trying to find the equation of our line, like any line, that's going to be of the form y equals mx plus b. So ultimately, to address the question of what is the equation of the tangent line, the final result is going to be something of the form y equals mx plus b. And now we talked last time about how one way that you can always determine a line precisely is that if you have a point and you have a slope, you know the line. Because if you think about every line through this point, each of the lines through that point has a different slope. If you knew the slope of the line through that point, you would know the line exactly. So if you know your point and you know your slope, you know your line. In the last example, we were given what the point was. In this case, we aren't given what the point is, we're just given where the point is. The point is at x equals 0. So we know our point is going to be of the form 0 comma something. Let's try to figure out what that point is. Well, that point is a point that's on our function. And every point on your function is of the form x comma f of x. You put something in, you get something out. What you get out is your y, what you put in was your x. So to figure out what you get out with this function, we just need to put this into our function. So if we look at f of 0, that's going to tell us the y coordinate on our function associated with x equals 0. Plug in x equals 0, that's a 4 times 0 plus sine of 0 plus 2. Let's see, 4 times 0 is 0, sine of 0 is 0, add 2, that's 0 plus 0 plus 2, that's 2. So now, we know our point is not just 0 comma anything, we know our point is 0 comma 2. That's something. We have our point now, and our point is something, but it's not everything we need to find the equation of our line, because now we got our point. What else do we need to be able to nail down what our line is exactly? Well, we need the slope. So if we get our point, part of the battle, once we get our slope, then we have all of the information that we need. And then the question is, man, what are we going to do? How are we going to find the slope of our tangent line? Well, you can always find the slope of the tangent line by using the derivative. The derivative is precisely the slope of the tangent line. So to find the slope of our tangent line at x equals 0, we just need to use the derivative at x equals 0. So f prime of 0 is going to give us the slope of the tangent line at x equals 0. And for this case, that's going to come out to be cosine 0 plus 4. Cosine 0 is 1. 1 plus 4 is 5. So now we know our slope is 5. And when you think about that, that tells you that your line is not just y equals mx plus b, but it's actually y equals 5x plus b. We know the slope is 5. And now, echoing the point that we have, no pun intended, that whenever you know the location of your x comma y and you know your slope, you know the line exactly, which makes intuitive sense, you can actually see that in your equation, because once you know the slope is 5, the only thing you need left to figure out what the line is b. And if you just knew x and y, you'd know b, because then b would be the only unknown remaining, and you know what x and y is because we took the time to compute that. The x and the y was 0 comma 2. So you plug in 0, 2, 0 for x, 2 for y, and that would give you, for y equals mx plus b, y equals 5x plus b would become 2 equals 5 times 0 plus b. Well, what that says 2 is 0 plus b, so that says 2 is b. Aha, we've got our line. Our slope was 5, our y-intercept is 2, our line is y equals 5x plus 2. And the long story short is this. If you know your derivative, you have a way to find the slope of your tangent line. And if you have your original function, you have the ability to find the point of interest, because you would need the y-coordinate corresponding to the x. But once you find your point of interest using the original function, and once you find your slope of interest using the derivative, because that's what the derivative does, it finds the slope of a tangent line, well, once you have your point and your slope, you have your line. And you can always use your information about your point and your slope with y equals mx plus b to figure out what ultimately the b is. Once you find the slope, you have the m. Once you use the x and the y, you find the b, and then the problem is solved.